so we're going to start super easy, okay, with common denominators. And then we're going to work all the way up to the point where we actually take and we put the adding and subtracting with the dividing that we did on Friday. Okay? So the last couple are a little bit uglier. All right? But these first few should be really easy. So ultimately our goal is to decide how do we add and subtract rational expressions with different denominators. We're going to use common denominators just like we did when we were in elementary school and we added and subtracted fractions. Okay? So our common denominators are just going to be polynomials. So there's going to be some factoring involved in here, likely. All right, fill in that blank. All right, we are going to add and subtract. Notice this is with like denominators. So to add or subtract rational expressions with like denominators, simply add or subtract their numerators. Then place the result over the common denominator. They're saying that A, B, and C are polynomials. C can't be 0 because you can't have a 0 denominator. So basically what we do is we keep that same denominator and we add the two tops together. Or we keep the same denominator and we subtract the two tops. All right, so it doesn't get much easier than this. All right. So let's take a look at one of these. So if you're going to get one of these, you want one of these on the test. Okay. So do we have a common denominator?
Yeah.
What is it? 4x. And if you do have one, don't try to simplify yet. Wait till the end to simplify. And then we're simply going to add across the top. So 7 plus 3, what's 7 plus 3? 10. Does that simplify? Does 2 go into both of them? Yeah, and we are under multiplication, not addition or subtraction, so I'm allowed to cancel. So 2 goes into 10 how many times?
5.
And into 4? 2. So 5 over 2x. We do want to see it in lowest terms. You do not need to make a mixed number. Please don't. Okay? I don't want you to make a mistake making the mixed number. Okay? All right, let's look at the next one. All right, do we have a common denominator? What is it? X plus 6, good. And then, so again, we just go across the numerator, 2x minus 5. Is there anything else I'm going to be able to do with that? No, you're done. Okay? All right, so really quickly, I want you to try example 3 and example 4. They might have uglier exponents, but it's the same idea. You're doing 3 and 4 right now. Okay, so on number 3, what's our common denominator, everyone?
3.
Good, and then what'd you get across the top? 3. Do I have to really show my work of writing 2 plus 1? No. Okay, if you did, it's okay, but it's not, not necessary. Does something cancel?
Yeah.
What?
3.
3's. Okay, what's left in the numerator? 1 over x squared. Good. All right, let's look at 4. So what's your common denominator on 4? X squared plus 1. Good. Okay, what is the across the top? What'd you get?
2x squared plus 2.
Plus 2. Now, could I factor something out?
Yeah.
Yeah, what factors out?
X squared?
No, out of this numerator. 2 comes out, right? What's left behind?
X squared plus
Oops. So what cancels?
that. The 2x plus
All right, and what's left?
2.
2. Okay. You always have to look and see if it factors once you've added or subtracted to make sure that you don't have something that you can cancel. Okay. So once you get to this step here, it's like what we did last week. Okay? So let's try the next one. So go ahead and fill in those blanks. So to add or subtract two rational expressions with unlike denominators, find the least common denominator, or we call that LCD, which is basically the least common multiple of the denominators. All right. Then you rewrite each expression using the LCD, then add or subtract using the procedure for like denominators. So again, A, B, C, and D are going to be polynomials. C and D can't be 0. So let's talk about how they got this. The common denominator was C times D. Everybody got that? Okay. So this one, the D is missing, so I have to multiply top and bottom by D. Does that make sense? Okay. What's missing in this one? C. So I have to multiply top and bottom by C. They just reverse the order here, okay, on the CD. All right, and then it's a common denominator, so we keep the common denominator, add across the top. On this one, it's the same deal. Add a common denominator, subtract across the top. Okay, but we're going to do that with more than just single letters. We're going to use polynomials. Okay. So let's try this. Oh, before we get into that, we're going to take a baby step. Okay. We're just going to find the least common multiple. That means we need to factor first. Okay. And we're going to do all kinds of factoring here so we can find that LCM. All right. What is your greatest common factor in this first one? 4. Good. What's left behind? Are we done factoring? No. What can this factor into?
X plus 2x minus.
But I also want you, remember how you did factor trees? You want to break that down as if you were doing a factor tree and get it into its prime. So what times what is 4? 2. 2 times 2. And you're going to see why here in a second. Okay? And then, I don't know why I'm using a different color yet. Not yet. Blue. All right. What is the greatest common factor here? 6. Okay. So I'm going to pull that out. What's left behind? Minus 4x plus 4. Good. All right. What is... So I've got to use the magic x. What's going to go to my magic x?
4.
Good. Two numbers that multiply to 4 and add to negative 4. Good. And again, I'm not going to be super cool. Okay? I'm going to be uncool right now. And then what does the 6 break into? 3 and 2. All right. You guys have the boxes on your desk right there, right? I want you guys to get out a box of colored pencils. So everybody get out a box of colored pencils. If you don't have one of the boxes, we'll get them from the front here. Not all of them got put back out. Okay? So get out a box of colored pencils. Pass that one back. Okay? Boxes are useful. They've got all kinds of good stuff in there. There should be a box of colored pencils for everybody. Okay? Everybody have a box? Grab a box of colored pencils out. Get out a red pencil and a blue pencil. Okay? Red pencil and a blue pencil. Okay? Doesn't matter what shade, just get out red and blue. I'm going to show you how I see this. Okay? Okay. You ready? I'm going to use light blue because I already used dark blue. All right, everybody has colored pencils? A red pencil and a blue pencil. Okay, here we go. So what we're going to do is in the two groups of things that we factored, we are going to circle every pair that matches with blue. So use your blue pencil first. So I see a 2 that matches. And I see an x minus 2 that matches. So circle everything that matches in blue. We are going to write down everything that matches one time. How many times? One time. So we're going to, because we're trying to get the least. All right. So I'm writing down a 2 and an x minus 2. Okay, now you're going to use your red pencil. Okay. And underline everything else that's left behind. Then you write down everything that's underlined. Okay, so I'm going to write it in red. 2 times x plus 2 times 3 times x minus 2. That's ugly, right? So we're going to clean that up a little bit. And hopefully our denominators don't look quite this ugly, okay? But they're having us practice it. So I'm going to multiply together my 2, and my 3. So what's 2 times 2 times 3? 12, good. And then I am going to go to being super cool now. I have how many of these x minus 2's? 2 of them. So I'd write x minus 2 squared, and then we've got the x plus 2 left behind. Okay? That's what we would write for our least common multiple. So let's try that again. Okay? Got to get good at this part before we do the next part. All right, so I'm going to pull out a different color again here. I'll do purple. All right, I'm going to break this down, this 5x cubed. I'm going to break it into 5 times x times x times x. So do that in your regular pencil. Okay? All right, what's our greatest common factor here? 5x, good. What's left behind?
X, 2x,
Minus
3.
3. Okay, so we're going to use our blue pencil. Circle everything that matches. So we're going to circle a 5 and what else?
5.
And x. One single x out of each of them. How many times do I write down what's in blue? Once. Okay. Then I'm going to get my red out and I'm going to underline everything else that's left in red. And I get to write down everything that's underlined. So I'd write x times 2x minus 3. Okay. How would we write that simpler? 5x is squared? Cubed. Good. Right idea, wrong number. We're on the right track. All right. That would be our least common multiple, or what we're going to call our least common denominator here in a few minutes. Okay. All right. We're going to start the next one together. Okay, and I'm going to have you finish it. So, what is our greatest common factor in this first group?
8.
8. Good. What's left behind? Good. What's our greatest common factor of the second group? 12. What's left behind?
X squared plus x minus 6.
Good. I could break both of these down way more, couldn't I? So what about this 8? Instead of just writing 2 times 4, what could I write?
2 times 2 times
2 times 2 times 2 times x minus 2.
2.
All right. Which eventually would be 2 cubed, but not yet, right? We don't want to be super cool yet. All right, what's this thing going to break down into?
3, 2, and 2.
3, 2, and 2. Okay, and then what do I have to do on this piece here? Magic x. Good, so that hasn't gone away. So two numbers that multiply to negative 6 and add to 1, what are they?
3 and 2. Negative 3 and 2. 2, negative 2. 3. I don't know those combinations.
It's okay. You're fine. Got to just slow down a little bit. All right. What I want you to do is I want you to do your circling, underlining, and find your least common multiple. So everybody try that, the last part of those steps here. Okay, so everybody's trying that right now. Circle in blue, underline in red. Okay. What did we circle?
The 2, another 2, and
X minus 2.
An x minus 2. And how many times do I get to write that down?
1.
1. So 2 times 2 times x minus 2. All right, and then we underlined everything else, right, in red. So 2, 3, and x plus 3. So 2, 3, x plus 3. And then you had to simplify it. So what did we simplify it to? What was 2 times 2 times 2 times 3?
4, 8, 24.
24. And then we had the x minus 2 times the x plus 3. Okay?
We don't FOIL.
No, don't FOIL it. Do not try to multiply that back together. Okay? I'd rather you leave it like that. You know, I know you understood what you did, rather than you making a mistake going further. Okay? All right. Let's now use this in a fraction problem. Okay? Now, you guys, I just showed you a technique, right? If the technique works for you, great. But on every single problem, do you need to circle in blue and underline in red? No. Okay? If you need to circle in blue and underline in red and that helps you on the test, you by all means get out those colored pencils. Okay? But you don't have to do that on every problem. Okay? But if you're getting the problems wrong, I recommend you go back to that technique I just showed you. Okay? All right. If I broke these guys down, would there be anything they have in common? No. So our LCD is going to be 7 times 4x, right? So now what I have to do is I have to decide what's missing in each denominator, and I'm going to multiply by the what's missing. So in this denominator, compared to our common denominator, what's missing?
7.
So I multiply top and bottom by 7. So what's 3 times 7?
21.
Do I really need to worry about multiplying the bottom? No, I'm never going to write that down again, okay? I'm only going to multiply the top, okay? Because the bottom we took care of already. What's missing in this second denominator?
4x.
So I multiply the top by 4x, and I get negative 4x. All right. There really isn't anything I can do other than multiply the 7 and the 4 together, right? This is the point where I look for, is there a greatest common factor? Is there something I can cancel? There isn't. So that would be our final answer right there. That one was pretty simple. Okay. All right, let's make it a little tougher. Is there anything I would circle that's in common?
X.
It's a binomial, so do I circle it? No, it has to be the whole thing, right? So when we're talking binomials, you'd have to be able to circle. So there's nothing I would circle, so this would be a red underline, right? I'd write down both of them. So x plus 1 times x minus 3. Okay, in the first term, what's missing in the denominator?
X minus 3.
Good. We're going to distribute the 3. So we get 3x what?
-9.
Good. What's missing in the second denominator? So I multiply by x plus 1. Do you see why I don't multiply? I show my work on the top and the bottom. It would get messy. Okay? When you're writing these out in your homework, give yourself extra space. Don't put it this squished together. Okay? I tried to make them bigger, I think. Or maybe I didn't. No, I didn't this time. Sometimes I try to make them bigger in your notes, and I apparently didn't do that. All right, I'm going to do what with this 2? Distribute. What do we get?
2x.
Plus 2. And you notice you're a plus sign right here, so there's nothing extra to distribute. You got to watch for minus signs in there. You think I'm done? No. What should we do in the numerator? Not distribute.
Combine like terms.
Combine like terms. There we go. So it's 3x plus 2x.
6x.
5x.
5x. Negative 9 plus 2 is what?
-7.
Negative 7. Is there anything that I can factor out at this point that's going to cancel with the denominator? No. So that's got to be our final answer right there. Okay. All right. I'm going to go to my purple color now. Okay, so watch how I do this one. Okay? I'm lazy and don't like to write out a million steps.
Me too.
I know I've got to factor this, right?
Yeah.
So what kind of factoring is it?
-x.
Good. So two numbers that multiply to 3 and add to -4.
-3, -1.
Everybody okay? -3, -1? All right, so right underneath here, I'm just going to write that down. So I didn't rewrite the whole thing. I just said, I know that that's going to be the same name as this. Okay? So I'm going to use this from now on for that denominator. Okay, blue pencil, what would I circle?
Next one.
X minus 3. So how many times does that get written in our LCD?
One.
just once. So x minus 3. Again, you like the technique, use the technique. Okay, I'm going to keep using it throughout this lesson probably here. I would underline the x minus 1 in red, right?
Yeah.
And I write that down. So there's my least common denominator. So, in the first one, what's missing from the least common denominator?
X minus 1.
It has an x minus 3 and an x minus 1. Is there anything missing?
Uh,
No, so I get to keep this, right? So I just write x. In the second denominator, what is missing?
X minus 1.
So I have to multiply by x minus 1. So what am I going to do with the 5?
Distribute.
Good, and what do we get when we distribute?
5x.
Good. All right, what do we need to do in the numerator?
Combine 1 and 2.
Good, so what's x plus 5x?
6x.
And then we've got this x minus 3 times x minus 1. Check your numerator. Does it factor in any way? No, there's no GCF. There's nothing that's going to cancel with the denominator, so this has to be done. Okay. All right, let's see what comes up next here. Is it that one? Yeah, how are we doing on time? Oh, we're good. All right, so does the first one factor at all? Look specifically at the denominator. Is the denominator factor or is it done? It's done. Okay, what about this denominator? Does it factor?
Yeah.
What does it factor into?
X plus 5.
Okay, good. What would we circle in blue? Good. X minus 5 would get circled in blue, and I'm gonna keep doing it. See, oh, I didn't get my blue switched.
Oh my.
Gotta have the blue. All right, blue and blue. So I write that down one time. And then in red, I would underline the x plus 5, and it also gets written down and included in my LCD. All right, in the first term, what's missing from my common denominator?
X plus 5.
See how with the colors, it makes it really obvious what's missing too? Okay, so again, if you like it, use it. If you don't like it, you don't have to use it. Okay? But you got to get the problem right. All right? All right, distribute. What do you end up with?
3x
3x
squared.
squared plus 15x.
Good. In the second one, what's missing in the denominator?
Nothing.
Nothing. So what do I write down? Be careful. See the minus hiding in there? Minus 2. All right. What do you think I need to try with the numerator?
Magic X.
Magic X. So two numbers that multiply to -6 and add to 15.
-2. Oh.
Does anything work? We have choices of 6 and 1 and 2 and 3. Is anything going to work to add to 15? No. So we're done. It didn't factor in the numerator. Okay? And again, don't foil those back together. It's okay. The only time you would is when you look multiple choice, right? And then it should be obvious because when they foil back together, isn't it the x squared minus 25? Okay. Let's try the next one here.
I got this more.
Okay. All right. Okay, so we've got to factor both of them, right?
Yes.
So let's do a magic X on the first term there. So two numbers that multiply to -12 and add to not negative X, -1.
6. No.
-4.
And 3.
Yeah.
Do we all agree with that? Okay, and I'm going to just neatly write it underneath here. All right, what is your greatest common factor in the second group there?
12.
12, good. What's left behind?
X minus 4.
Lauren didn't sound too sure. Should she be sure?
Probably.
Yeah. All right, she's right. Okay, so I'm going to get out my blue pencil again. What would I be circling?
X minus 4.
X minus 4, good. So we've got x minus 4. And then I would underline in red everything that's left behind, oops, which is the x plus 3 and the 12. I'm going to throw the 12 in front and the x minus 3 behind, or x plus 3 behind. All right. Now let's take a look at what's missing. So I should have 2 reds and a blue, right?
Yeah.
Okay. So what's missing in this denominator here?
12.
So I multiply by 12, I get 12x. What's missing in this denominator here?
X minus 3 plus 3.
What are we going to do with the 5, everybody?
Put it
Distribute.
on the
Distribute, so plus 5x plus
15.
15. Okay. So, let's go ahead and combine like terms on the top. What's 12x plus 5x?
17x.
17x plus 15. Oops, it's not right. And then the denominator we leave just the way it looks. 12 times x minus 4 times x plus 3. Is there anything I can factor out of the numerator that would cancel?
No.
No. All right, so this is our good final answer. Maybe. It's not wanting to box, not wanting to write. Okay. On example 13, okay, what do we need to do with our denominators first? What kind of factoring is this? X, and what's this one? Okay, so I want you to try this on your own from beginning to end. Try the magic X, try the difference of squares, okay, and then also see if you can get it added in with the LCDs and all of that. Okay, so see if you can get it done. On your own, I'm going to give you about 2 minutes, okay? All right, let's check it and see how we did. So, Laura, what'd you get in your magic X? 3 and 3, good. Okay, so we have x plus 3 times x plus 3. Okay, we're not going to be cool right now, no. All right, let's see. William, what did you get for the difference of squares? Good. All right, I'm going to go to my blue pencil. And Candace, what did you end up circling?
X plus 3.
Good. And how many times did you write those down?
Just 1.
Just once. Good. Okay, and then we're going to underline everything else that's left behind, right, guys? So we end up with another x plus 3 and an x minus 3. Okay, so in the first one there, in the first term, Wesley, what did you end up multiplying this one by?
X plus 3.
Good. Because there's another x plus 3 missing. So what did you have to do to multiply that, everybody? I hadn't shown you one like this yet.
Foil.
We had to FOIL it. Okay, so if you didn't FOIL it, it's fix it up. Okay, if you at least got this far, you did great. Okay, that was all the new stuff. Mrs. Ballard didn't show you the FOIL yet on it. All right, so what's x times x?
X squared.
X squared, good. X times 3.
3x.
3x, 1 times x. X and 1 times 3. 3, good. All right, in this second one here, what's missing, everybody?
X plus 3.
An x plus 3. Wait a minute, what happened? This one should have been x minus 3, so let's fix our signs, right? So we've got a negative, so we just have to swap the signs. Negative 3x and a, not that, that's okay. A minus 3 at the end. Let me fix it even better than that, okay? So it should be a minus, a plus, and a minus. Minus, plus, minus. So make sure that that's fixed correctly. All right, so this one is x plus 3. So what am I going to do with the 6? Distribute it. So plus 6x plus what? 18. Good. All right, so we've got x squared. Let's see. Negative 3x and x is what?
Negative 4x. Right?
Negative 2x plus 6 is what? Positive 4x. And then negative 3 and 18 is what?
18, 16, 15.
15. Okay. And then we've got the x plus 3, the x plus 3, and the x minus 3. Let's check that out. Are there two numbers that multiply to 15 and add to 4? No. Is it okay to leave my answer like that?
No.
You can. That's okay. You don't have to be super cool, but we'd rather see you be super cool, right? Likely on the test, if it was a multiple choice, you would see x plus 3 squared times x minus 3. Okay? All right. Let's try, I think there's one more of this type. There's one that has 3, right? We're going to try example 14, and then we're going to call that good for today and finish it up tomorrow. Sound good? Okay? We'll deal with the fraction over the fraction tomorrow. We'll save it for a Tuesday instead of a Monday. All right, so what do I have to do with this piece right here? You guys, don't freak out that there's 3 terms. It's just a little bit more work. It's not much. It's not any different, okay? So 2 numbers that multiply to 6 and add to 5. 3 and 2. So we've got x plus 3 times x plus 2. All right.
Can it be 6 negative 1?
No, because there's no negative in the middle. Okay?
Okay, go.
All right, so I'm going to circle what matches. So what matches? X plus 3 and what else? X plus 2. Okay, so you need to have an x plus 3. You need to have 2 blues in each one and an x plus 2.
Yeah.
There's no reds this time. All right. So what's missing in this first denominator?
X plus 2.
X plus 2. So I multiply by x plus 2. And we distribute in. What do we get? Good. What's missing in the second term? Be careful when you distribute in. I need to distribute in
Negative.
-3. So watch whatever sign is here should be grouped with whatever's there. So what's -3 times x?
Negative 3x.
And -3 times 3 is?
Negative 9.
Good. All right. And then what's missing in this denominator? Nothing. So I'm just going to write down what? Be careful. -1. All right, let's do our good old combining like terms in the numerator there. So x squared, what's 2x minus 3x?
Negative x.
Good. And -9 and -1?
Negative 10.
Good. Over x plus 3 times x plus 2. I always check my magic X to make sure to see if it works. So two numbers that multiply to 10 and add to negative 10 and add to negative 1. 5 and 2, 10 and 1. Did anything work? Nope. So this is done. Okay, and again, do not FOIL that denominator together. Okay? All right, so I want you to open your Chromebooks up. Let's look at haiku and see what homework is here. And you should also remember